Hello everyone, welcome to my channel. This video is about the concept of adsorption and different type of adsorption isotherm like Freundlich Langmuir Isotherm. At first I will tell you what is adsorption, what is the difference between adsorption and absorption, then why adsorption occur, then the different type of adsorption isotherm. At first, what is adsorption? And adsorption is basically the surface phenomenon of an substance, surface phenomenon. And what is absorption? Absorption is the bulk phenomenon. One major difference between the adsorption and absorption is the adsorption is surface phenomenon while absorption is the bulk phenomenon. And another thing is that for absorption, the concentration of the whole system is mostly uniform. The concentration is uniform in whole system. But in case of adsorption, the solute concentration in the surface is more than that of in the bulk. That's why it is told as the surface phenomenon. For the discussion of adsorption, we have to know two terms. One is adsorbate and one is adsorbent. What is adsorbate and what is adsorbent? Adsorbate is the substance which is adsorbed in the adsorbent. Adsorbate is the substance which is adsorbed in the adsorbent. And adsorbent is the substance on which absorption occurs. And adsorbent is the substance on which surface of which adsorption occur. It means that you can correlate with the solvent and solute. Solvent is the system where solute can dissolve. Here adsorbent means the system on which surface the adsorption phenomenon occur. And adsorbate is the substance which is adsorbed in the adsorbent. Now, what is the reason behind the adsorption? That is why adsorption occurs. What is the driving force of the surface molecule to adsorb another type of molecule? Now, this is a system and these molecules are the bulk molecules and these molecules are the surface molecule. These molecules are the bulk molecule and these molecules are the surface molecule. Now if you see this particular bulk molecule, then you can see that the force acting on this molecule is cancel out each other, because the force acting on it or it sends the force from each side. Each side if it sends the force. That's why these are intermolecular forces, and that's why as the force acting on it from each side, each different side, then it is cancelled out, and this molecule cannot sense any force at all, because the force acting on it is cancelled out. But if you see the individual surface molecule, then you can see that there is no force on the upward direction, because there is no another type of molecule here present. That's why the force acting on the surface molecule is not cancelled out. There is a certain residual force in the surface molecule, and this residual force is the driving force to adsorb the another type of molecule on the surface. As the force acting on the bulk molecule is cancelled out that's why it can't sense any force at all, but there is a residual force in the surface molecule. That's why it adsorbed, and the driving force behind the adsorption is the residual force, which is present only in the case of surface molecule. This is the only reason behind the adsorption. Now, adsorption is an exothermic process. Adsorption is an exothermic process. Why adsorption is an exothermic process? Actually, this is the adsorption. This is the adsorption. These are the maybe these are the gas molecule or liquid, and this is the surface of the substance. And let's see the red colored molecule, which is adsorbed on the surface, When the adsorption occurs, then the randomness of the substance decreases. That means the entropy of that substance decreases when adsorption occurs on the surface, because the randomness decreases. When this red molecule is here, then what is its randomness? It is reduces when the red molecule is here. And in another way, you can see that what is the randomness of the substance of the molecule which are in the surface of the system will be decreased when it adsorbs another type of molecule. That's why the entropy of the system is decreases when adsorption occurs. That means the del S is negative in case of adsorption. And we know that relation del G is equal to del H minus T del S. Here del S is negative due to the adsorption, and as del S is negative, then this term will be positive term. As del S is negative, then the relation between del G will be del H plus something positive value. And from thermodynamic consideration, we know that for getting a spontaneous reaction, del G should be negative. Del G should be negative for getting a spontaneous reaction, and adsorption is a spontaneous reaction. The driving force behind the adsorption is only the residual force, which is present on the surface molecule. And for getting the negative del G value, the del H value should be negative, because the del S is negative, hence this term will be positive actually. Hence, for getting the negative gives free energy, the del H should be negative value, and as del H is negative means the reaction is an exothermic reaction. Hence, the adsorption phenomenon is an exothermic phenomenon. There is different type of adsorption isotherm. Mainly three: Freundlich Isotherm, Langmuir Isotherm, and B.Sc Isotherm. Today I will discuss only Freundlich and Langmuir Isotherm. At first, what is the adsorption isotherm? Basically, adsorption isotherm is the relation between the amount. Here we are considering the adsorption of gas molecule. Now, the relation between the amount of gas adsorbed on the solid surface and the pressure of the gas at the constant temperature. This is known as adsorption isotherm. Why isotherm? Because these occur at a constant temperature. That's why it is known as adsorption isotherm. Now, in case of Freundlich isotherm, the equation is x by m is equal to k into p to the power 1 by n. Now, what is x, what is m, what is p, what is k, and what is n? X is the amount of gas adsorbed. X is the amount of gas adsorbed M is the amount of adsorbent, P is the pressure, K is a constant, and N is an integer. Now this is the how much gas is adsorbed in m gram of adsorbent at a constant temperature, and this is the relation between the extent of adsorption and the pressure at a constant temperature, and this is the this equation is known as Freundlich Isotherm equation. Now at the lower pressure, at low pressure, x by m is equal to P, x by m is equal to P at low pressure, and at high pressure, at low pressure, x by m directly is equal to P, there is no power on P, and at high pressure x by m is equal to P to the power 0, is equal to P to the power 0, and there is also the term K. Now at low pressure x by m is directly related to P, and at high pressure x by m is not related to P, and this is the condition at the moderate pressure. Why this is occur? Because there is in the adsorbent there is a definite number of adsorption site, and when the pressure of gas increases, then when all the adsorption site is occupied by the gas molecule, then there is no another adsorption site is available for gas molecule to occupy. That's why the if in that case, if you increases the pressure, then it will not adsorb any more gas, because there is no adsorption site is vacant. Up to which pressure adsorption site is vacant, it will adsorb the gas, and beyond that pressure it does not adsorb any further gas molecule. That's why at high pressure the x by m value is not depend on the P. Beyond this pressure limit, if you increases the pressure, then also the adsorption, the amount of gas adsorbed is not increases at high pressure. And the Freundlich Isotherm, what is the equation for Freundlich Isotherm? This x by m equation is the equation at the moderate temperature. And if you take the logarithm of this equation, then you can get that log of x by m is equal to log k plus 1 by n into log p, which is a straight line equation. Then another is the Langmuir isotherm. There is some assumption for Langmuir isotherm. What are the assumption? That is the adsorption is the monolayer adsorption, that is one layer of gas adsorbed on the adsorbent. Further, double layer, triple layer formation is not occur in case of Langmuir isotherm. Second thing is that the solid on which, that is the adsorbent, solid has uniform surface, and there are fixed number of sites for adsorption of gas molecule. There the solid, that is the adsorbent, has uniform surface, and there is a fixed number of adsorption site for the gas molecule to adsorb. Third is that the all sites which are available for adsorption, the all sites are equivalent, and each site can adsorb only one molecule. The fourth assumption is that there is no interaction between the adsorbed molecule. There is no interaction between the adsorbed molecule. And the fifth one is that at equilibrium, rate of adsorption is equal to rate of desorption. At equilibrium, rate of adsorption is equal to rate of desorption. And by using these assumptions, you can derive the Langmuir isotherm equation. Now if you see if you see this, then you can see that this red colored molecule is adsorbed, then again dissolved. This is adsorbed and again dissolved. So at equilibrium, so here adsorption and desorption occur simultaneously, and at equilibrium the rate of adsorption is equal to the rate of desorption. Now the rate of desorption is proportional to the theta into n, where n is the total number of adsorption site and theta is the fraction of adsorption site occupied by the adsorbate. This rate of desorption is depend on the fraction of the adsorption site occupied by the molecule or occupied by the adsorbate, and it is proportional to the theta into n. If the rate constant of the desorption is denoted by Kd, then rate of desorption is equal to Kd into theta into n. And what is the rate of adsorption? The rate of adsorption will be proportional to the pressure of the gas, and what is the vacant site available to adsorb the gas, that is 1 minus theta, and which is multiplied by n, that is you can get the total number of adsorption site is vacant for the adsorbate, that is the rate of adsorption is proportional to will be proportional to 1 minus theta into n into P, that is pressure of the gas. And if Ka is the rate constant of the reaction of adsorption, then the rate of adsorption is equal to K into 1 minus theta into P into n. And at equilibrium, in the assumption I already told that at equilibrium the rate of adsorption is equal to rate of desorption, that is at equilibrium Kd theta into n is equal to K 1 minus theta P into n. This is the equilibrium condition, and if you rearrange this, you can get that theta will be equal to K1 into P divided by 1 plus K1 into P, where K1 is equal to Ka by Kd. If we rearrange this equation, that is Kd into theta into n is equal to K 1 minus theta P into n, then you can get the relation of theta, that is the fraction of adsorption site is occupied by the adsorbent, that is theta will be is equal to K1 into P divided by 1 plus K1 into P. And here it is interesting that this theta relation is not depend on the total number of adsorption site, that is n. Theta is not depend on the total number of adsorption site of n, because in this relation n is cancelled out. And here the important thing is that the gas is monoatomic gas. When gas is monoatomic gas, this relation is valid, that is theta is equal to K1 into P divided by 1 plus K1 into P, where K1 is equal to rate constant of adsorption divided by rate constant of desorption. This is the Langmuir Isotherm equation. That's all about this video. In the next video, I will show you what will be the Langmuir adsorption equation, isotherm equation for n atomic gas. Today I show you what is the Langmuir isotherm equation for monoatomic gas. In next video, it will be for n atomic gas, and another type of that is multilayer adsorption isotherm, that is the Bate isotherm. In my next video, I will discuss these two topics. Thank you for watching. If you like my videos, please like it, share it, and don't forget to subscribe my channel. Thank you.